This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Okay, let me just get this on. Okay, hello. Okay, so welcome back. First of all, a huge apology from me to you for being sick last week. Yes, I wasn't able to deliver the lecture. You may have noticed that the actual recording that I had promised would arrive is also not arrived. But that will happen on Wednesday. You will have that lecture recorded. The issue that I had, which was an absolute devastating blow to my working pattern, is that my Mac, which I have been in love with for the last 5 years, played up to the point that I now want a divorce from it. The thing is, it automatically updated to Catalina. Many people had no problems. I was one of the very few who ended up having Catalina produce 24 partitions on my hard drive just for fun. Suffice it to say, what it meant was that everything that I had on here was locked into it. I could access it, but I couldn't use it. So I spent countless hours trying to copy all the information off in a way that didn't lose any data. And most of you will be thinking, why didn't you have backups? Why didn't you have backups? Well, I normally have what's called a time machine that keeps a backup of everything. But the way Apple distributed Catalina caused that time machine to fail. So I was on the phone with them for 2 hours trying to get a resolution, only for them to say, ha, 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 nothing we can do. Yeah. So anyway, so I'm just realizing now that there are a few things that are not working, which I wasn't able to test at home, and that is the third monitor. If I recall, I had a driver on there that was allowing me to have multiple monitors, I think. It seems to be showing that I have multiple monitors, but it's not actually showing the information on the monitor, so I don't know what's causing that. So the reason I'm mentioning that is that normally I will program, and it's just fixed itself, so there we are. Normally it would just work when I plug it in. It's just worked now, so, okay. You can tell that I've had a bad week, right? So there's a few things that we need to discuss, just to be clear. The first one is the assignments. Let me just put this on AV so I can see you guys. Sorry about the bright light. The assignments, I understand that many of you are having problems with the verification for assessment 5. Is that still the case for everyone? Hands up if you have verified correctly and had feedback. You have? You've had your feedback and it's all worked. Okay, well that's really good. The system is set up, everything is in place and it should work. It accepts your submission, and what it tends to do is it then hangs on the server side. That is not something I have any control over, so I have already raised a ticket, an urgent ticket, to get them to release what's called a backlog. So for some reason, ever so randomly and occasionally, the submission system gets a backlog where it can't overcome. I would have thought by now it should have resolved, because I did address it last week. I will chase it up, obviously, ASAP. But suffice it to say, keep trying. The system is working. All you're looking for is verification so that you can review your code to make sure it's okay, right? So just checking that everything's not the same. I'm just trying, yeah. Anyway, that was the first thing. There was something else that I needed to address as well. Oh, the peer review. Okay. So it seems like every year the peer review causes us headaches, just because last year and the year before, the timeline for you to put the peer review in was very short, and many students missed the deadline, which meant that some people didn't get documents to review. This year I've given a large sort of open area of time for you to put your documents in, but this year we're finding that you can only submit one document, and that's causing a problem. Now, my suggestion and advice on this is that the document that you submit will only be read, it's never going to be run. So we're not going to run it and test that particular document on LMS. We will be running your code on the server, of course, but on the LMS peer review, it's only going to be read. So what I would suggest, if you're comfortable doing this, is to put each of your classes on top of each other in a single file, a text file. So if you've got one class, just put a one class, two classes, one on top of each other, and so on, and submit that one file as a single file. If you want to call it a text file, call it a text file. The key is that nobody needs to run it, so it's not a runnable class that they're going to test. What they're going to do, what you are going to do when you receive the document, is read through the document and provide reasonable feedback that shows that you understand the code, that you can follow the code. And if anyone's done very complicated code, somebody did say they did very complicated code, that's okay, just review the code as you understand it. The code that you submit, your code that you submit, is not marked on the LMS, right? So the student who's reviewing your code and you get the feedback has no influence over your mark. You get the mark for submitting, you get the mark for putting it on both the server and on the LMS, so you get your grades for that part of the work. Your code is also then reviewed by hand, looked through by our marking team, and you will get your marks from that. The code that you submit for review simply gives you good feedback. So if you want to know what other people think of your code, you get to find out. And again, you have to be professional when you write the review yourselves. Make sure your review is very professional. You know, no mocking. And then that review that you produce gets graded. Did you understand? You know, there's 3 or 4 elements that we look at for that review to make sure that you understood the code and you provided a suitable review for your peers. So, just to reiterate, submit one file, I think, that's all you can do from what I understand, and just tie all the files into one file. So one text document with all your classes on top of each other. Hopefully it's not too huge. And that should allow you to submit your document for the distribution. And then on the date, I don't have the dates in front of me, but the date will come where the time runs out that you can no longer submit, and then at that point, at that moment, the system then automatically looks at all the submissions and distributes 3 per student. So you'll receive 3 documents for you to review. And again, the review isn't going to be huge. You don't have to write an entire essay, you know, 6 pages long. We're just talking about an honest appraisal of what you see as a means to give positive yet critical feedback to your peers. Does that make sense? Does anyone have any questions on the peer review that I haven't addressed? Yes? That's a good question. I can find out. I don't have the date on me now. I think if you go on assessments on LMS, there's a dates table, dates and times table under the banner of assessments, and I think I'll check that now actually. But before I do, I just wanted to quickly address this monitor that is kind of working but not. Yeah, so the dates are on there, except for the only date that's changed is the assessment 5, which I've given an additional time without any penalty for lateness, just because obviously it's not your fault that there was issues there. Yeah. Any other questions? Yes.
Is the file type of the code tied to text file only? Or would you be able to
Well, so you're asking if the file type that we submit to the peer review fixed on text only? Yeah. I'm not sure. On my side, what I've allowed is any file type. There is an option to say only specific file types, you know, and I've said no, just any file type. So I'm hoping it allows any file type. But I don't want to add complexity by zipping and stuff. You can zip, and if you've done that, I'm pretty certain I'm going out on a limb here and suggesting that all of you know how to unzip and things, right? Anyone who doesn't understand what unzipping is in the context of computation? Okay, everyone's happy. So yeah, any file type that's accepted, but it'll be one file. So yeah, but I would advocate just going for a text file because it's simple and there's no issues, no complications. I know on a PC there's different types of zipping, so you might need a different zip program. Again, it might be different on a Mac, so I would be worried about that. So to save any problems, perhaps if you haven't already done so, stick with just a text file. And we'll see what happens. We're in it together, right? So we'll see. Again, it's the I don't even know what to call it, but it's almost like the demon of the peer review. I know it's been 4 years actually. Even the 4 years ago when I wasn't teaching, there was issues with peer review. But we persevere because it is a good practice. It's really good for you guys to have that peer influence within your code, and it's really useful. We've found that in general. Right, let me just quickly fix what you're looking at here. Okay, that's that. So I want to... Nope, that's not what I wanted to do. Oh, dear Lord. Right, so that's that. Okay, try again, guys. Right, okay, now we're good. Oh, so like I said, my MacBook, up until today, I'll turn this off so I can see. Up until today, this last week, I would have praised this to the earth and back, to the ends of the earth and back, and said that Macs are perfect and wonderful, because I've used them for quite some time. But after my latest, can I call it a bout with Apple? Because I really was on the phone with them for some time. I'm concerned now, and I would add today's class, as you will see when I click this, I hope. Let's see, yep, is all about exceptions. And interestingly enough, it ties really well into my experience over the last week. So the mantra is, if anything can go wrong, it will. You're not seeing, oh my God. Okay, forgive me again. How do I fix that? Okay, let's try that one more time. Right, you can see that. Right, that's fine. So why can't you see? Thank you for telling me. Oh, dear Lord. This is what happens when everything changes mid-flow. I didn't even choose. Right, so that's there. Okay, good. That's doing. So far, so good. Let me try that one more time. You still can't see that. Why? Okay, I'm going to just pull this out again and try it again. I don't know why it's doing this, guys. I think it did this the first time I tried it in the beginning. Forgive me, this is such a pain. Nope. Oh, dear Lord. All right. Oh, dear me. Okay, that's coming on now. I don't understand. Okay. I'll try it one more time. You can't see that, can you? No, you can't. So, and there's nothing I can do about it. Oh, dear Lord. Okay, so what I'm trying to do is show you what I've got on my screen here. Can you see from the back? Okay. I'll talk as I try and work through this. So we're going to be talking about exceptions. And interestingly enough, as I'm experiencing right now and showcasing live, if anything can go wrong, it often will. I do not know why this is not giving me if I do that, has that made a difference? Okay, now you can see what I can see, but that doesn't help you. Ah, I can't even find the screen now. Aha. Okay. Yes. Okay, now I've lost it from there, but that's okay. That's better than nothing, right? Okay. Okay, so today we're going to be talking about exceptions. Oh my gosh, there's Demons Gremlins. Anyone watched the movie Gremlins? We're going to be talking about exceptions and the concept that if anything can go wrong, it will, and you can see that it will. Generally, error handling is something that's either trivial if you understand it or quite complex if you don't. Most programmers who haven't gone into the depth of error handling will generally just use a thing that we'll go into later called a try-catch, which is to tell the computer to try something, and if an error happens, catch the error. And that is true, we will be doing that, and hopefully you'll see how that works. But error handling in Java is a little bit more object-orientated than that. In general, so you have two ways that you can detect errors. Oh my God. Sorry, guys. There's two ways you can detect errors. Oh my gosh. There's gremlins, I tell you. The general approach is that, can I have a show of hands? I'm not sure I'll see the hands at the back, but how many of you code in C? Hands up, a few of you. And how many of you that do code in C have used the malloc command? Right, so you've used the malloc command. And how often, and be honest, do you check the return value for malloc when you... Okay, less, okay. Okay, so generally, the general term is that most of the time, an application or a method can only return a single value, right? So you'll generally return, in other languages such as C, you'll return like a 0 or a 1, depending on whether you have an error or not. So 1 is to say everything is fine, and 0 is to say that there's an error, or vice versa, depending on the situation that you're in whichever language you're in. So it's very common for programmers not to actually check to see whether an error has occurred and just carry on regardless. And that is when you start to see things that actually sort of don't provide the meaningful feedback that you wish to see when you're running your code. Sorry, something about having things go wrong that gives you a dry mouth. So in Java, another thing is to have your program exit. So we've had sort of, some of you guys have supplied work and you said that you've not received feedback on your applications through the system. And generally for some of you, that has been because you've used system.exit. And that exit process, which I'll explain throughout this class, actually it inhibits or stops any program from running further. So it literally cuts off the application completely, regardless of what's happening. And that's been the case that we've seen as well. So the horrible, terrible way of dealing with errors is that you don't look for them. You don't check for them. You ask for user input, and they give in the wrong input, and it causes your system to crash. And that's okay when you're learning. But as you do more sort of professional programs, you need to obviously look into putting some form of system in place that doesn't allow that to happen. The second thing, obviously, is to have your system just break and stop, and make it unable for you to be unable to test. Now, what we have is this concept called exceptions. Exceptions give you the best of both worlds. So an exception works, it's a class-based object. So an exception is a class, and I do have, I'm not sure if this is going to work now. So, okay, I'll have to do it like this. So what we're looking at here is the API, right? You get rid of that. So this is the Java API, and what I wanted to show you, looking over my shoulder, which I didn't really want to do. Okay, I'll do Control F. Is that even going to work? There you go. So we've got this is an in-out or a drive exception. And what I want to show you is that you can see there's a hierarchy here of exception. which is an object. So there's an object class called exception. The one I really wanted to show you was this one. So this is the exception class. And as you can see, it's a subclass of throwable, and then everything is obviously a subclass of object. So in Java, I'm just trying to get this working. In Java, we have the exception class, which we use in mainly two ways. So the two ways that we use exceptions is throwing and catching. Now, most people, if you've done sort of Python or some other language, you'll be used to catching errors. So catching an error is quite a simple thing. You know there's an error going to take place, so you put code in place to say, if this error takes place, do this thing, right? In Java, it also allows you to say, I want to create an error. I want to throw an error, almost like throwing a tantrum. So if you know an error might occur, you don't have to deal with it. Instead, you just throw it and you say there's an error, and the error will just propagate through the system, which I will explain as we go along. So the first is throwing. The second is what you do about throwing. So exceptions being classes, they have methods that you can access. So when you create a new exception, in the case of throwing an exception, you obviously get the toString because it's a class object, so you can use the toString to retrieve a message, I was going to say English, but it could be any language, a readable message to the developer or to the user that gives some context as to what the exception or that error was. Then there's the get message, and there's quite a few others as well. I do have some examples to show you in a moment. So you have the get message, which returns a string details about the error, or null if there is no error, of course. And then what you've seen quite commonly, 100% guaranteed, I would say 99% of you will have seen what's called a stack trace. And that is when you run your code, and then it just gives you that stupid, ridiculously long error that you look at and go, okay, where is the real error? So the stack trace is basically for the developer, for the programmer, for you, to enable you to see at what point your code broke and what other areas of that code it was responsible for or working towards or working in. Excuse me. So the exception class gives a broad overview of what's wrong, and it's being a class, it's something that you can also create yourself, so you can generate your own error class and utilize your own errors within your own code. And something I've experienced too much this week is having error numbers that is designed for the developer to know what that particular error was. It gives no meaning to me, but gives meaning to the developer. And often that's something that you'll see as well, is that people create their own error codes that they can use to develop their code further. So let's look at throwing. If you throw an exception, you're basically signaling that an unexpected turn of events has occurred. Now, throwing an error is different, completely different, to a runtime error, right? So when you throw an error, generally it's because you're aware that something's going to take place, that there's going to be a problem. And the idea of throwing an error, as opposed to catching an error, an error throw is to say, look, I know that what I'm about to do is likely to cause a problem, and this is the type of error that I'm going to cause if I run my code. But, and this is the big but, I don't know what to do about it. Right? I don't know what to do about it. So the idea there is that you're writing code that you know may fail, but you don't want to deal with it. So you throw an error, and what it does is it returns the error to the calling class, and it will keep following. If that calling class hasn't dealt with the error, it will call the next class above it, and it will follow the chain all the way up to the main method to try and solve that error. And if you don't have a method of dealing with the error that you've thrown, even in the main method, that's when you'll see a stack trace, and the system will just burst out and say, I don't know what to do, I'm broken. Does that make sense to everyone so far? Any questions? If I take my glasses off, I shouldn't do that when I ask you if there's any questions. But I've got streaks on them. Any questions? I can see you now. No? Okay. So, like I said, if the caller doesn't catch it, so if you have a method that calls another method, and that method that you've called throws an error or has an error and doesn't catch it, then you as the calling method has to do something to catch that error. And if that calling method doesn't do, that's when it goes all the way back right to the beginning of the program. Again, if it's never caught, the program's aborted. You could use this as a way to, if you're running method within method within method within method within method within method within method, and you decide you want to jump back to main, it is possible to just throw an error to return back to main and have a catch in main to run all the way back to the main method without having to propagate through. But that's really bad practice, and I'll show you what I mean by that again in a moment. So to throw an exception, you simply use the keyword throw with a space, and then you provide the exception. Typically, we create an exception just for that purpose. So we generate a new exception at the time of creating a throwable exception. So essentially, if this is an object that you've already created, you can throw the exception. But if you haven't created the object and you just want to create a new exception, you use the keyword throw, new, and then you give it your exception class. Now, if I go back to here, oh, that's not very big. Sorry, I'm trying to find my mouse. Aha, where is my mouse? Can you see my mouse? Aha, there. Okay, let me make this bigger, and then just make this up. So these are just some. These are just some of the exceptions that are available to you, and there are much, much more than this, of course. The one I was looking at earlier would have been, there is IO exception. They've got unsupported look and feel, transformation exception. So all these exceptions are available. They're basically exception classes, and the importance of them is that each exception is kind of part of a hierarchy. So if I went back to IO exception, if you look here at the hierarchy of object, throwable, exception being kind of almost the lowest form of exception, obviously throwable being beneath that. If I go to IO exception, you can see IO exception sits on top of exception, sits on top of throwable. But if I went to array out of bounds here, array out of bounds exception, you can see that sits on top of index out of bounds, runtime exception, exception throwable object. And of course, this hierarchy grows depending on the type of throwable object that you instantiate with the new keyword. What do I mean by that? Well, essentially, I'll show you an example, actually, in code, whereby the lower down, say this is the parent, then each one of these are children, and the lower down towards the parent you go becomes the dominant exception. What do I mean by dominant exception? It means that if I throw an exception, it's more dominant than throwing an array out of bounds exception, if that makes sense. I'll show you what that means very, very soon. Don't worry. Oh my gosh. Hello? Oh my gosh. Ah, okay. I tell you. So going back onto the example that we've been using in all of our lectures and the missing persons and such. if you said we checked if the name was null, and in previous times we've just said if it's not null, then do something, but if it's null, don't do something else. In this example, what we're showing here is that if you create a new person, you give them an age and a name, and then you check if the name is null. Well, we don't want it to be null, do we? So we want to make sure that everyone has a name. So then you can throw a new null pointer exception, and then you provide a string for that exception. So one of the things to think about with exceptions, not only do they maintain a stack trace or a trace of where the error was produced, it also stores and maintains a readable string text that you can use for whatever you need to. Now, in some of the jobs that I've had in the past, I've been using an error stack trace in the background to update to a server that the developers, the team, were able to see. So every time we threw an error, that error wouldn't show to the user at all, but what it would do, it would actually highlight on one of our servers to show that an error had occurred and where it had occurred, and there was information in there for us to be able to look into that code and repair it without the user having to complain and make a fuss about. And I would imagine it's kind of what happens when you use an application and it says, do you want to send anonymous data to the developer team so they can fix bugs? And that's the same kind of thing, if that makes sense. So what happens is, when you throw, so at this point here, if name is null, so this is null, you can see that, yeah. If name is null, then it throws the exception, and at that point, it doesn't continue with that method. So that exception is thrown, and it leaves that method. That method is then destroyed, if you will, or doesn't continue. So this.age equals age and this.name equals name is never executed because there's an exception being thrown. That exception then is thrown, and whatever called that class, whatever called person or create used person, has to then deal with that error. And if that calling class can't deal with the error, that calling class also then has to throw the error, and so on. And this can continue for as big as your program is, eventually until it hits the main method where it has to deal with it or create a spillable error. So that was throwing an exception. Throwing an exception is a vital part of programming. It's similar to an assertion in some ways, or you're asserting some condition, but what you're saying is, look, I want this to actually be dealt with. This has to be dealt with at this moment because it is a problem within the program as a whole. So handling exceptions, it follows this form. So you say try, use the try keyword. So essentially what you have is, if you've got a block of code and you know that that block of code is going to cause or could potentially cause an error, you'll have seen this when you had the scanner class. And if you ask the scanner to take in an integer and somebody puts in a word, you know it's going to give you an error, right? But if you put the call to that next integer, to that user inside a try block, then that call will be handled. So even if an error occurs, you have some way of controlling what happens next rather than just having an error. So the key is that you have the try keyword, then you have, you must have brackets, so then you have open and close brackets, which forms a block of code, and then you put your code as you would as normal within that code. If there are no errors, then the code jumps over the catch keyword and continues along its merry way. However, if any issues are occurred, then the code, that code block, no matter where it is, wherever that issue happened, on whichever line it happens, the code exits that try block at that point and joins or jumps. So no matter where it is on this particular code line, if there's an error, it will jump to the catch block. So you've got the catch keyword that comes after this curly bracket, and then I'll explain this in a minute. This is essentially just creating a new variable of type exception, wherever the class is. And then this block from this bracket then, so this bracket to this bracket, that will then execute as soon as an error has been detected. Now, this catch, if you look at the word catch, it almost looks like a call to a method, which in fact it kind of is, right? So by using the catch keyword, you're calling the catch method and you're providing the parameters of a exception class, which you can choose from the list that I showed you, or one of the thousands, and I mean thousands of exception classes that are available to you. Choosing the right exception class for the error that you're looking at is by far the most optimal way of handling an error. This exception class here can be any class of type exception, but what often, it's probably bad practice, but quite often what is often used is just the hierarchical exception class, just exception, and then the variable var. This is the variable that's created for the lifespan of this block of code. So essentially what's happening is you're calling a catch, you're saying there's an error happened, then you're calling the catch block, and then everything that's inside this brackets here is then executed, assuming there's no other errors. And that variable, var, we normally use the variable e, just to say exception. That's the norm. It can be anything, of course. But that variable only exists within this block. So it's generated for this block, and it exists with this block. And what it does, it provides to you information about the error. So it has a toString, it has a getText, and some other text things. There's quite a few methods that you can look at. If you've got a good IDE, you can have a look at them. I'll show you a few later. And that executes in this, this catch clause. Now, there is an issue. If you say, for example, put in there IO exception. So you're looking for an in-out. So you've asked for the computer you've asked Java to read from a drive, and you've said, look, I'm expecting there could be an error from the drive. And then when you run your command inside the try block, you hit an index out of bounds exception. The problem with this particular example is that because you've put IO exception here, it'll ignore, or it will not be able to handle the index out of bounds exception because you've only specified IO exception. Does that make sense? So the specification of the exception class at this point within catch is critical to detecting the correct error. Now, the good news is that you can have as many catches as you like. So you can choose an array of catches. You can have try, open bracket, your code, and then catch with the exception, and then the block. And then you can have another catch, and then the exception and the block, and another catch and the exception and the block. So you can have as many catches as you like with different exceptions that it's catching. As I'll be explaining in the pitfalls later on. By doing so, you do risk that some of your catches will not be caught depending on the hierarchy. If you remember when I pointed out that the exception was the sort of parent of most exceptions, except for throwable, then if you have an exception, I'll show you examples in a minute, hopefully it'll solidify what I'm saying, but if you have an exception class above, in your code above an IO exception class, and you have an IO exception error, because the exception class is the parent of the IO exception, or one of the parents of the IO exception, then it'll catch in the exception only, and it'll miss the IO exception, right? I'll show you some examples, but hopefully when I go into the coding, that will make more sense. So essentially, you have a try, you have a catch, and that's pretty much the basics, if you will, of catching or handling the exceptions. Now, so the code that could go wrong, again, if you write a try-catch code and it doesn't throw an exception that matches the class that you have, then it will just throw the exception to wherever it was called from, and that will enable the calling class or the calling method to deal with the error that you're facing. And And that's pretty much reiterating what I have already said. So it completes with that. Yeah. So first, the code that may go wrong is put inside the inside the try block. If it completes without exception, it ignores, just skips over and carries on as if nothing had happened. If it throws an exception matching this exception class or one of these exception classes, then it runs the catch clause, which allows you then to deal with whatever's happening in a controlled manner. And then after it's run the catch clause, so if it runs the try, it breaks the code off, stops what it was doing, jumps to the catch, runs the catch clause, and at that point it then carries on after the try catch. So it doesn't return to the try. So if you've got like 10 lines of code in your try block and the 5th line of code causes an error, it will jump over the remaining 5, run the catch clause, and then carry on and ignore the last 5, right? So they will never be run if there's an error. So that's just something to be aware of. So the catching parameter has 2 roles to specify the kind of exceptions to catch. So that's where you put in the exception class, the type of exception. And again, it is common practice, not good practice, bad practice, bad practice. It's common practice just to put exception.e in there, just because when you're learning and you're not familiar with the API, as you will become as you practice, you don't know why your computer's going to crash. You don't know why Java's going to crash. So you just want it to not crash, right? So you end up just sort of saving it to, you put an exception in there. I'll show you what I mean, again, in the code examples in a minute. But the right way to actually code is to put the right type of error that you're looking for in that catch, so that it knows how to handle it correctly, rather than just ignore it happened and keep running, if that makes sense. Again, you can have multiple catches, and if no catch matches the error that's occurred, or if no catch is a parent of one of the errors that have occurred, then the catch statements will break at that point and return it to the calling class, right, which normally is higher up the chain, if that makes any sense at all. Okay, so what we're going to do now, we're going to try and do this. Sorry, I want to look over my shoulder. So I click New Paul, it probably want me to. Okay, so we're going to do a few of these today. Right, so I'll bring that back on in a minute. So the location to go is to bit.ly tchristi or quickpoll or qp.unimel.edu.au tchristi. If you could get your devices and jump to there, the more the merrier. It makes me happy to see lots of numbers on there. And the question we're going to answer is, what will this code print? So what will this code print? Whilst you're doing that, I'm going to... There we are. Let's have a quick little look at the code. And make your selection. So it works on phones, it works on iPads, it works on Macs, it works on PCs, anything that has a net connection. Did I switch this on? Is everyone done? Everyone worked it out? Shout more time if you need more time. Okay, I'll take that as I move ahead. Okay, so, right, so the majority saying D, then the next saying A. There's a huge number of you that have joined in on this, thank you. Okay, so what is happening with the code? You've got to try. You're initializing I as 1, checking if I is greater than 0, which is true, and in which case you're throwing a new exception. So what happens with the new exception? you jump to the exception, which is of type exception. You can see exception matches here, exception, exception. And then you're saying system.out print y, then you're finishing the code and you're saying system.out print z. So in this case, the answer is correct as yc. Oh, there is more. See, yeah, I should give you more time then. So it couldn't be x because x is printed out after the exception has been thrown. So if you remember, as soon as an exception is thrown, it stops all activity then from that point on and jumps out of the try block. So if the exception is thrown, it jumps out of this try and jumps into the catch if and only if the exception matches the exception thrown has to match the exception caught, right? So if they don't match, or if the exception isn't a parent of one of those things that match, then it will not catch. And then, of course, it couldn't be just y, because the code then continues after y with z. So hopefully that makes sense. Make sense, everyone? So the answer is yz. So the pitfalls. So as I mentioned, oh my gosh, there it is. You need to always try for good programming style to put the most specific exception as a check in the catch, or to throw a specific exception rather than a general exception, because it allows you to understand what is going on with the code more succinctly than if you just catch. You could use just exception, right? Just you could say exception, exception everywhere, not use IO exception, not use area out of bounds exception, not use any of the other multitude of exceptions that do come up. But you will get less information back and less control over your code. So you do need to be more specific with the descendant classes. Now, the descendant classes being the children. And avoid just using the sort of parent class of exception. So in this example here, this is what I was saying. If you say try and you do something and you get an error and you say catch exception, as I mentioned before, the lower down the chain, this one will be caught directly, and this one here will never be caught because number format exception is a child of exception. So because exception was checked first, exception will be called. So this catch here will be run if an exception is found, and this one will never ever be accessed, which is a shame in that term. So to make this work, you would have to put the exception underneath and the number format exception above, and then it will check the number format exception. If it isn't a number format exception, it will carry on. But because the exception is the parent class, it'll just accept that as the overall overriding exception and continue there. And therefore, this catch will never run at all. Now, you can have multiple catches, as many as you need, but only one of those catches will run. So if you try and an error occurs, it will jump. If it then jumps into a catch that catches the correct error, only that one catch class, the catch clause, will run, and every other catch clause will be ignored. I hope that makes sense. So this is just going through the inner workings of the catch block. It's basically to recover from an error. You can use exception block. You have several methods that you can use. Get message is a common one, so that will give you just the message. So rather than having that huge bump of stack trace, that error that you would normally have, this will give you a little bit more succinct, just the message saying this is what the error was, and it won't stop the program, it will carry on. So you can just carry on working and just have that information for whatever you need to do with it then. And again, if none of the catch clauses can solve the problem, or if you have one catch or any amount of catches and you can't solve the error, the last catch can just throw the error. So you can throw the error forward. So you can say, look, I can't deal with it. I've tried. I thought it would be any of these problems. I don't know how to resolve those as a programmer. So I'm just going to throw the same error or a different error. So, for example, if you knew, say, one of 5 errors could happen, or so, and you check for all 5 errors, and none of those errors actually are found something new that you weren't expecting, you can pass that error straight forward without dealing with it, so that the calling class can deal with it. And by doing a throw, what it does within the Java ecosystem is it enforces the calling class to either deal with the error during compilation time, so that before you're running, or to throw the error again further up the chain, right? So the idea of the throwable sort of concept is that by implementing throwable, it forces someone somewhere within the code to have to deal with that code at that given time. Does that make sense? Okay. So, again, if you want to throw the same, so if you remember I mentioned that the catch, it's the exception, and the variable name would normally be E. That variable name is an object of that exception class. And that exception class, that now in this case called E, is the object that you can pass. So you can throw that object back and say throw E, and it throws whatever that error class was back to whoever called it. Or if you just want to wash your hands of the whole error, you can throw any other error. You can, as long as you throw something when an error occurs within the catch block, as long as you throw something back, that would satisfy Java and enable the code to carry on, where the calling method has to deal with whatever class you throw an error of. I'm not sure if that makes perfect sense to you, but that's how it works. So we looked at the throwable, so we can throw errors. We've looked at how to catch errors, right? So we can catch them and hopefully deal with them. But what we've kind of introduced is the concept that if your code terminates, you've got 10 lines of code and it terminates at 5, it's jumped 5 lines of code, it may not have completed its task. And this is quite commonly a problem, because often you need to make sure that certain things take place. For example, I have a software company that I run, and we've got a project at the moment where we write a certain file to a license holder, and that file has to be in place during the code running cycle to ensure that all licenses are live and everything's working. And if that file isn't modified during the run cycle, it can cause problems to everyone else with the same license. So essentially what I'm saying is that if you say, for example, build a file that's dependent, absolutely dependent on only one person using it, let me reiterate what I'm trying to say. You have a situation where you want to make sure that only one task is performed. So you make a file and says, if this file exists, then that person is using it, and if the file exists, no one else can do this job. So it locks down the whole sort of ecosystem so that only one person can do the job. But that person doing the job has an error, and it jumps out and doesn't delete the file. So then the person goes into the catch clause, does whatever it does, and then can't complete the code that needed to be completed, and the file remains in situ. In such a situation, the next person comes along and says, oh, I want to work on the same task. They see the file is present and says, somebody else is using it. But that somebody else has crashed, they're not using it, but that's stuck. So what we do, we have this concept called the finally block. So the finally block is a block of code that you can implement with or without a catch that says it doesn't matter what happens, whether there's an error or not, then this code will be run. And essentially, if you want to close loops, or if you want to save the state of your variables, maybe somebody's filled out a huge form and an error occurred, and there's nothing worse than filling out a huge form as a user, and then an error occurred, and then you have to fill out the whole form again. So a cool thing to do would be to have a finally block that says if there's an error, store the variables ready for later so that they can be called back at an instant's notice. So the finally block works exactly the same way. At the end of the curly brackets, you simply put the word finally. You don't need to give it any error because it's going to run regardless. And the code then to execute when an error occurs is run. You also, in this case, you don't need to have the catch clause either. So you can essentially have a try finally. So you wouldn't have a catch clause. And again, I got an example to show you of that too. Looking at the time, guys, I've kind of run over the 3 o'clock sort of deadline. We'll have a quick 5-minute break, and we'll continue straight after. Yeah, of course. Of course.
If we don't have catch, only try and fail, right? Is that symbol like these statements? You're trying to find whether like the source that you're looking for is matching your requirements, and if that's really matching.
No, because the final will run. I see
Regardless, right?
Regardless, yeah. So
even if some error,
even if there's an error, the final will run. Even if it's caught, even if it's catch, it will run. If there's no error, it will run. So it's kind of like saying, look, if something goes wrong, this is my plan. Do this. Make sure you do this, even if something breaks. It's kind of like a safety net.
I was thinking, like you said, regardless whether we have error, we're going to run it. But we don't have a catch in this case. In a specific case, is that really makes sense? Because the try is all about finding error, right? Exactly. But you have no catching. That is catching error. Is that really okay?
I see what you're saying. It does. I mean, there are reasons why you could do that, where you don't really care about the output. I've actually got an example I'm going to show.
Right.
I'm going to ask you guys as a quick poll that very same issue. So you'll see. It's not a brilliant solution, but you can do it. It's legal. It's legal.
Sure, I can do it, but like it's not the most
useful. Yeah, it's not the most useful solution. Yeah.
Thank you.
Yeah.
The final answer is say if that's a code, right, for whatever the assignment. That's great. Project. Are we supposed to do it like that, or we can convert the file into a PDF in the next?
Good question. Yeah, I would convert it to PDF.
In the like being, right?
Even in this, even in Word, just because you want to make sure that anyone can read it, because you don't know whether they have Word, maybe they can't buy Word.
Yeah, sure. But now sending the Java files, right? Because in the normal submission, we can actually submit the Java file as well, right? Because right,
So
to the server.
Right. That you must do that. You won't get marked. So
But we're not gonna submit the Java file to.
You don't need to. No. Just a text file with the code on there, so people can read. Yeah.
And it's only because once I copy paste all of the codes into the Word or I don't know PDF, right? It's less readable, I would say.
Right.
The structure.
Yes, it is. I see your point. So that's why I would recommend you probably do it as a PDF because it holds the structure. Whereas if you put it in Word, it might change the structure depending on their fonts. Just double check what you submit so that there's the style. But again, it doesn't affect you.
Sure.
Yeah, you won't lose marks.
On the structure.
On the structure, no. But you may get feedback saying rubbish structure.
But it doesn't affect me anyway.
It doesn't affect your marks. No.
Okay. No. Also, just one more thing. I know that Java can create a PDF file, right, from coding.
Okay.
Like, are we supposed to have some coding and then convert this file into a PDF file, or we can simply click some button and then convert Polka.java into Polka.pdf?
I'm not sure.
I'll send it out.
I've never tried.
So,
yeah.
Thank you.
Yeah, thank you. Yes.
I only have a little problem.
Okay.
Yes, I was submitting assessment 5.
Yes.
And unfortunately, I submitted a wrong file. I resubmit my project.
Okay.
But I've already submitted once.
That's
so
okay. You can submit until Friday as many times as you want.
But I mean, is that will be influence my project because I resubmit the wrong file.
Oh, to your project?
Yeah.
So you got assessment 5,
yeah.
And then you got project 2 separate. So you submitted project 5 as
I submit my project into the assessment 5.
No, have you put your project then back to project?
Because
you have submitted the project to project as well.
Yeah.
That's okay. Perfectly fine. Just submit.
But I didn't do the verification.
It doesn't matter. So just resubmit your assessment 5 as lab 5.
Okay.
And you'll be fine.
So there won't be like.
There'll be no penalties, no nothing. I've extended the deadline to Friday at 5 p.m.
I mean, it won't influence my project.
No. No.
Thank you.
You're welcome. You're welcome. Yes.
Think of in the catch and that bracket, there is a exception class here, and the exception class has to be one of those in the API.
Not always. I'll show you. You can create your own. So the exception, you can create your own exception.
I can like scroll new and give my own exception name.
Yes, I'll show you how in an example. But you can create a class that is a type exception, and as long as you provide the two constructors, you can produce any number of exceptions that you wish. Again, you can create new exceptions that the API has never thought of. If you're working for an industry, let's say you're working for NASA, and they have a specific problem that only NASA would ever deal with, you can have NASA problems and have exceptions just for when a rocket goes off. Yeah.
Another question is about that finally. So if I don't have that finally, I just put my code after this catch. I think they will work the same as
No, because if the catch has an error, if there's an error, or if the catch can't deal with the error, then it will just move up the chain and it stops the code within that method. If you put the finally there, even if the catch has an error, it'll still run the finally. I'll try to run the finally.
I see. So if it throws an error in the catch, which means
Or if you throw the error, yeah.
we need to put this part of try catch in another try so that.
That's correct. The catch, yes, exactly. I'll show you with an example. But so if you throw an error, even if you're inside a try catch sort of situation, and you throw the error because you can't deal with it, whatever was running before, the method that you're running has to deal with that error. It has to do somewhere has to fix the error. So somebody has to catch it. If you can't catch it, throw it. And if they can't catch it, they'll throw it. And if they can't catch it, they'll throw it. And eventually somebody has to catch it. Otherwise there'll be a status error. Okay? No worries.
Why would you ever want to chunk a chunk of code and try?
Huh?
Why would you ever want to chunk of code and try? Because it makes me feel like if you're using this try section, right? It's just you not knowing what to guard from.
No, yes and no. So when you start using that file lineup, so if you want to read from a file,
Yeah.
you have to put in a try catch. I'll say, look, it's almost, it enforces you to try catch because there are times where you can't control what's coming in. Like, for example, you won't know if it's the end of the file, you won't know whether it's a binary file or a text file, you won't know whether the file name's there or the folder is there. It's all these errors that you have. And what it's saying is, look, if they happen, we can't continue. We don't know what to do, we'll just go, So you put in a try catch. It's kind of like
putting like a whole bunch of guarding statements or an identifier. Like basically, like for example, if you were going to give me a whole bunch of different data inputs, I'd have an entire class dedicated to figuring out what that file type is in the first line. And then from that, then it would process it.
But if you think of it as an object-oriented programming,
Yes.
and then the concept that you're working with other teams, that they're working on one part of the software, you're working on the other part of the software.
Yeah.
They don't know what you're thinking, you don't know what they're thinking. You have to work together.
Oh, I see.
Right? So they say, look, they'll say to you, look.
So this is why you chuck everything through try catches because you don't know.
You're
not controlling what the
that's right.
what the input is.
And that's right. And if you want them to deal with it, if they say, look, we're going to give you the velocity of the rocket at this point in a NASA program, and they say, but it could be a problem that an O-ring will fail.
Yeah.
But we don't. They'll say, look, we don't know what to do with that, but you do.
Yeah.
They'll say, look, we're going to throw the exception.
It's like, look, we're only just figuring out how to get the velocity from the rocket fuel. Your problem is that.
Yes. So then you'll throw the exception to them.
Yeah.
And then Java forces them
to deal with it.
Have to deal with it.
Yeah, because eventually if it gets to the top, you're done.
Yeah.
Cool. Sweet.
Okay. No worries. Yeah, no worries.
What's the difference between the get message and
It's very little. ToString will give you a slightly more erroneous message, and the get message, the difference is very, very subtle, almost nothing. So they're going to give you a string. The get message will give you a different, well, not always, but usually gives you a different sort of message. But if you call the object just the name of the object, it will call the ToString by default. And if you call .ToString, then it calls ToString because you're asking for it. But so the object will naturally call ToString on its own with no, so it'll return the contents of ToString without calling the method. Whereas the get message won't. And there's other messages as well. So if you look when you're coding and you press error object dot, it'll give you a list of all the different methods that you can use. Hopefully I'll have time to show you some examples on the screen. But the difference is subtle and almost nothing. As long as you've caught the error, that's good enough. And what you do with it is up to you.
So there contains no difference.
Yeah, there's different methods. Some give you just the name of the error. Some give you more information about the error. Some give you lots of information about the error. And it's up to you what you want. So you can choose, get the basic message, get the big message, get called ToString. Depends on how your code works.
So what about frames with stack?
That gives you the error you see when there's a problem. There's lots of errors. It's got line this, line that, line this, line. You know when you see when you have an error? That's the stack traces. You don't want to send people that. That's bad. Because then they can see all sorts of mess. We good? We good? Okay. Hello. Okay. Okay. Hopefully everyone's rested. So just reviewing the finally block, some of the questions I've been having, just details that the finally block is just called to sort of run code that saves data or ensures that a certain script is run before you lose all your data, if that makes sense. So the finally block is executed almost no matter what. We say almost because finally, for example, if you go into an infinite loop, so if there's a loop that just loops before and doesn't error, then the finally block will not execute. And another one is if you call system.exit. So if you call system.exit from inside the catch block, so system.exit is brutal, right? It's really violent and it just shuts the program down and doesn't care and it's done. So that's the end of that. So those are two conditions that I can think of off the top of my head why the finally block would not be executed. Otherwise, it's generally, most of the time, executed no matter what. So that's your safety net to make sure that code is run even if an error has happened. Do remember that your catch clause must supply a matching error for the error that it's trying to catch. Try hard not to just use the exception.e, which will catch the error no matter what, but it's not as elegant. So if you want to be a better coder, try and catch the errors that matter, and that way you can get very good information as to what is occurring. Again, if you've submitted code and not got feedback off the LMS system and you've used system.exit, that would be one reason why. Now, I want to quickly do another bit.ly. Let me just reset this before anything. New Paul. And the question we're going to ask now to see whether everyone has, oh my gosh, this isn't working. Right, what will this code output? What will this code output? Oh, you got a shout out. I can't see that. Oh. My gosh. Aha. I'll just hover it there. Okay, so go on your, go on the bit.ly or go on the quick poll. Let's see if we can get the numbers up. Oh, that's weird. Huh. Oh dear. Okay. I'll give you a few minutes. I'll give you a minute. So based on what we've already discussed, what will this code print? How many of you are frantically coding it? You ready? Everyone say, yeah. Yeah. No. Ah, dear. Okay, so it's kind of an even Stevens almost, right? So some say hello, majority are saying hello world, and another certain amount saying hello world exception. See if that's I'll keep doing this. I wonder if that's influencing you. Shame it's not a live feed. Well, let's look at what's happening. So you've got the try. You're saying system.out hello, so we're certain that hello is going to be called, but you can see that. And then you're saying system.out print students plus 1 divided by 0. Does everyone remember what a division by 0 does to a computer? It normally creates an error, right? So computers can't divide by 0. They just don't like it. And modern computer systems are designed to just spit out an error and say, I don't like it, I don't like it. So what we're having is we have an error, so then it goes to the finally catch, and then it says world. So we know it's going to print out hello, we know it's going to print out world. And then, so the correct answer is E. So if you had E, you were correct. The reason is that it wasn't, so this line couldn't execute because of the division by 0. And of course, that's why it can't be C. Any questions by anyone on that one? Seems to have thrown a few people. I can't see. No, okay. Oh. Say what? It actually catches the exception before world. It does capture the exception before world. In fact, I have an example. Yeah, I can show you this now. Oh my gosh. Where's my mouse? I've lost my mouse. Can you see? Oh, there it is. Oh dear Lord. Okay. Right, so what I have an example here that I've written. Okay, so, my gosh. Oh, there we are. So I've done a few exceptions here just to sort of show, but the one we're looking at is this one here, right? And the exception here, I don't know if that will get big. Oh yeah, I can make that bigger as well. So the exception is caught quite early, the division by 0, just simply because of the nature of the order in which Java execute things. So, for example, that division by 0 is executed first before the students, just because it's in brackets within the brackets. So that error is caught before the students. And so that it does detect the error early. It gives some default message, which is something I've put on the reciprocating class, which I'll show you later. And then it says hello world, and then gives the error, right? So it crashes at that point. So the hello is printed out correctly. The world is printed out after it correctly, but then the error has to sort of propagate. Because it hasn't been caught, it kicks out the error. Does that make sense? Yeah. What was the other question from here somewhere? Was there another question I had? I'm not sure what you're asking. Oh, the question. Oh. Ah, okay. Okay, yes, okay. So, yeah, okay, there's a fair point and well made. That's a typo. Oh my gosh, I can never find this. I don't know what you're talking about. Oh, you can't see it? Oh my gosh, why is it doing this to me? Okay. Do you remember I had a problem at the beginning? We're at slide, what, 20? Okay. Yeah, I don't know what you're talking about. That's what I was trying to say. Oh, sorry. Oh, sorry. Hold that thought. What was that? You were saying something quickly? Yeah. You're right. It's a fair point. Yeah. What was the question at the back?
Why would you ever write a try statement without having a catch? Because it seems kind of redundant.
It is. It's not good practice, that's for sure. I think the concept is just shared simply because it's legal. You can do it. It could simply be that you want to see the error. You want it to crash out. But the final is saying, look, I know you're going to crash, or you have a potential to crash, and I want you to crash because I don't want the program to carry on at this point if there's a problem. But I really need you to perform this bit of code. Such as, for example, I'll tell you a little story. Logging you out of an ATM. I was in a little town, a little farmer's market about a month ago with my daughter, and I saw this ATM, and it said Smart ATM. And I was like, ooh, wow, Smart ATM. What's so smart about it? I was really excited. Turns out you can just give it cash, and it can give you cash back, so I didn't understand that's all it was. But it had this touch thing, so I went over to it and put my touch on. So I touched my card on, no pin, right? And then I could get my money out. And then I was like, oh, I got my money, and I walked off, and I'm just walking off with my money thinking, oh, that was cool. And then I thought, oh my God, I forgot to log out. So I quickly ran there to this poor guy who stood there, and so I said, oh, I'm sorry, and I started pressing cancel on his button. Anyway, the point I'm making is, I'd never used this machine before, and I thought I'd left my bank account exposed and open, didn't realize, because normally you press finish and your card comes out, it logs you out and you know. So that's what the finally is doing, right? When you've done that, whatever it is, even if there's no exception, it's going to run this log you out sort of thing. And that just reminded me of the situation that I experienced, where I wasn't sure if they had coded it to allow me to log out. So in answer to the question, sometimes you may be happy to have the error as part of your default programming methods, and you just need to make sure that something's happening. Maybe I know with if you program in MATLAB, which is like another language, it's a very good package. It's free for your students to download. If you program in MATLAB and you open up a COM port to connect to a network, if it crashes during that connection, then MATLAB kind of holds the token to that COM port, so you can no longer log onto it because it's logged onto. And then you can't, even if you run the code again, you can't log onto that port again because it's active. So the only way at the time when I was using it a lot was to exit MATLAB and reload MATLAB again to do that. But if it had a finally catch and said, look, log out at this point, that wouldn't happen. Yeah? Right. What have we got there? Okay. So, as we mentioned, obviously Java's got a lot of exceptions that it already has defined for you. Quite a few of them. All of them are of subclass throwable, so they all have the attributes from throwable. So if you go on the API and you look up the keyword throwable, you can see that everything is inherited. Everything is inherited from throwable to every single class. So exception sits on top of throwable. If you have an error, so if you experience an error, there's nothing you can do about that. You can't protect yourself from errors because an error is what the JVM, the Java Virtual Machine, is supposed to take care of. So, you know, for example, if If you're using too much memory, that's the JVM's problem. And if the JVM can't do a garbage collection and can't fix that, it will give you an error, and in which case it's not an exception. You can't catch that, so that's not something that you can deal with. And runtime exceptions, you can, if you have a subclass that has a runtime exception, then generally runtime exceptions are considered to be errors in your code. So even if you catch it and it continues to run, your duty as a programmer is to fix the runtime error so that it doesn't happen, similar to what we did with the division by zero. That's an exception I could catch, I could deal with it, I could do something with it, but the reality is that's an error that needs to be fixed. So there's a distinction between throwing an exception and saying, I don't know how to handle this, please do something about it, or I do know how to handle this, I'll catch it and I'll do something about it. And there's a difference to having an error that shouldn't be there. So don't get too lazy and just put, you could really have a main method, try catch, and then run everything through your main, right? And catch exception.e, and then you'd never have a crashing program again. But you wouldn't gain anything from that, really. It'd be a very lazy way of coding. So that's fixing errors. So again, just to recap, that you need to catch the you should not catch the descendants first. So if you do have multiple catches, forgive me, then you mustn't just put exception first. You must put the hierarchy. So go on the API, find out the error that you're looking to support and protect, and put the youngest child, or the sort of deepest root, or whichever context you want to think of, first, and work your way down. So eventually that you have exception at the end, and that's the correct way of doing it. So runtime exceptions are things that you fail to prevent, and those things that you either should fix, or if it's part of the JVM, it's not for you to deal with. So normally things like null pointer exceptions and index out of bounds and such things like that. Those are things that you shouldn't just leave there because it's problematic further down the line. But again, it's fine to throw runtime errors or exceptions for others to catch as a part of the standard rule. Now, I've got another, I'm just thinking about the time, so I've got another thing here. We'll go through it quickly. So if you jump back on, just look real quick. Oh, there we are, let me just reset this. Oh, I can never find the mouse. New, okay. So this is another one, just a quick poll. I won't hold it too much. I'll work it with you, I suppose. So you've got try, string s is equal to null, system.out print s to uppercase, system.printout w, catch exception e, system.out print x, finally system.out print y, and then system.out print z. So what is the choice? Is it w, x, y, z, x, y, z, x, z, or y, z, or a null pointer exception? Okay, let's see how many of you have got the excitement to do this. There you go, 11. So 11, 12, 13 of you. I'm kidding. Okay, so the majority are saying X, Y, Z, and the answer is in fact X, Y, Z. So you're getting there. Good. Right. Oh. This is just reviewing the checked and unchecked exceptions. So simply put, that checked exceptions are exceptions that you deal with, unchecked exceptions are things you can't deal with. I think that's the bottom line. I'm looking at the time, so I'm trying to speed through this now. So just be aware that you'll need to be prepared to deal with or handle errors when they're thrown. Exceptions and errors are not your problem. So if you have an error that comes up, it's something that you generally can't deal with. I experienced one of these where I didn't realize if you put too much data inside a single method, then the JVM gives you an error because it can only hold a certain amount of megabytes per method in the structure. So the throws clause. So we've looked at try, catch. We looked at throw, so we're throwing an exception. Another thing you can do is you can attach the throws with an S. So there's a different throw and throws, yeah? So there's a difference between throw and throws. Throws is where you declare that at the beginning of your method so that your method can and possibly will throw an exception. By doing so, you force the IDE to issue a warning that the method that you're about to deal with throws an exception. And if it throws an exception, you have to either deal with it or throw it yourself. So the keyword is just simply throws exception, much the same way as you would when you, so at the end you have this is a public lost person, this is a method, the method signature, and then at the end, just as you would if you were doing it, if you were extending a file, you'd say throws and you'd give it the exceptions list that you're about to throw, and then you continue with your method. So I have some examples here. So there's some examples. So you have this is just a try catch, right? So I'm going to try and catch. I've got a try catch. I'm going to catch an exception. I throw out the exception. A don't catch, which I want to see what happens, and then I'll show you my exception in a minute. And do I have throw and throws? So the difference here is that you have try catch, tries to catch and throws an exception. And this is how you do the throws. You can see this is throw with no S. This is throws with an S. Throw is where you create an error. You're forcing an error to be created that needs to be dealt with. Throws simply says there could be an error of this type, and whichever method calls this throws has to deal with it. So what's calling throws? It's don't catch. I'm trying to see where don't catch is. So don't catch here. If I put don't catch outside of the try, it will tell me that don't catch needs to be kind of protected with a try and catch because essentially it's throwing. It has the potential to throw throws an error. So it's got the throws an error sort of issue. So I probably could just throw that in somewhere. So if I just go starting and put it there, so you can see now it's got a little underline there. Nope. And it says, unreported exception must be caught or declared to be thrown. So that's the sort of safeguard, you will. So if your method throws with an S some exception, then what it does is it tells the IDE that you've got to deal with it, and it won't allow you to compile if you don't deal with that error. So either you can throw it on or you can catch it. You can try and catch it at that time. So I'll just put it back in there for now. Oh, lost my mouse. And you can obviously declare multiple throws. You can throw you can have the throws with the S, multiple exceptions depending on your needs. Another thing. This is just reiterating what I've kind of said. So it obliges the callers to catch. So what I want to show you is you can define your own exception, which I've done in this example here. So you can see, I don't know if you can see, we're in lecture 11. So I've got an exception class here. And all I've done here is created a class like you normally would. So if you want to create your own exception, you just do it generally any old class. Call it what you like, and you extend exception. And by doing so, it creates that class as an exception. In its very nature, it becomes an exception. You supply a constructor that resorts, at least this is the minimum standard, so it resorts to super. So the constructor resorts some message to super. That can be anything you want. And also you need then a constructor that takes in a message, a text message, and passes that on to super as well. So that's passing it on back onto the exception class so that it can deal with it. This is the bare minimum, right? So you can create your own exceptions as you need to do. And even though there's a bazillion different exceptions available, there are times where you need to create your own exceptions to follow that sort of hierarchical object-oriented structure. And this is essentially what I've just showed you. So you have, if you create your own exception, you extend exception class, and then you have to create two constructors, one that takes a string and one that doesn't. Both of those pass a string to the super. That's pretty much covering that. So any questions on exceptions before I quickly change the subject? Any questions? Everyone happy with everything? Okay. All the code, I don't know if you've seen, so I've got this structure here. What I propose to do next week is to actually give all this structure to use for all of you to have as a review code for you to play with after next week's lecture, so that you have everything together that we've been working on or looked at throughout the class. Okay. So this is just a quick and short overview of software engineering and some basics that I wanted to cover. So essentially, as a software engineer, if you're planning on pursuing this as a profession, there are certain principles that you will adopt or need to adopt. Some of you already are proficient programmers, I realize. Some of you are just learning and just starting and taking those first steps. And essentially, every sort of software engineering project that I've ever worked on has had what we call a slide, where the project has somehow not met its mark, either by financing, by time, or by error. Generally, you have to build in, you have a thing called a project scope, where you go to a client and you discuss what they need, and you do build in a buffer to say, like, this is the bare minimum what we can get done in the given time that you're giving us. And often there'll be an extension where things do go wrong and things will go wrong. So according to these statistics anyway, so 1 in 6 software development projects fail outright, so you don't actually meet the mark. I've seen quite a few software development projects fail, but I've never had one fail on me, thankfully. 1 in 2 projects complete or go over budget, and this is usually, the going over budget generally is because your client will often change the spec halfway through the project, and that's very, very common. And 1 in 3 projects succeed, and which costs obviously billions every year. Reasons for failure: unrealistic or unarticulated goals. So you can't, you're trying to be Superman, but all you provide is Batman. Although he won. Inaccurate estimation of needs and resources. That's quite a hard one to deal with. Sort of broadly defined system requirements. The more detail that you can get from your clients and offer back to your client, the better that would be. Poor project management. This is a difficult one because project management is as diverse as business is often, depending on who's project managing. But the way that I'm going to go over 2 different examples of project management that are often used in software engineering, and also the inability to manage complexity. Just a quick example of projects going out of whack. So in 2005, the police have this software called LEAP, which stands for Law Enforcement Assistance Programme, and it's pretty basic. But they had a budget of 50 million to upgrade that to something more modern. By 2009, they blew the budget to 130 million. 2011, they had to then blow 200 million. And as far as we know, the project was never completed, so there's 200 million provided for pretty much nothing. So the thing is, they're still using LEAP. LEAP looks like this. I don't know if I can... Yeah, you can see that, can you? So it's pretty old. No, it's not letting me do that. Okay. And this is just a real-world example of a project that fails. And this happens quite often. I was working on a project in the UK for IBM, and we were creating... my job was to create a front-end or a visual aid for what's called an Internet of Things. Internet of Things is basically lots of devices attached to one system. And all the devices I was reading from their systems using different resources. And essentially, halfway through the project, they changed the names of all the products that were sending data, so we were getting nothing. But that set us back. These kind of things happen all the time, whereby things change during mid-flow that causes problems. Now, a common thing that you'll see is people saying that they want you to have what's called a software life cycle or a waterfall life cycle. And this is pretty old-fashioned, and I think not one that is often, I would say it's not a great way to produce software unless the software is almost boilerplate, very simple and obvious to produce. So the design requirements you take first, then you get the requirements first, then you design, and then you start implementing the code, you then validate the code, and then you provide maintenance. Most of the time is spent in maintaining code, by the way, dealing with bugs and such. You've probably all seen this kind of thing, the project lifecycle, the waterfall model, where each section is done in turn. But the issue that you have with this, and often have to deal with, is that changes do happen mid-flow. And the further down the chain that the changes happen, the more costly it becomes for the developer. Sometimes you'll have a certain structure that you've designed specifically for that project. And as the project changes after the design, maybe even in the verification change, sometimes it takes a lot of work and effort and lots of money is wasted going back to the design stage. So you kind of almost have to flow water back up. But in a perfect world, the waterfall model should theoretically work. And you'll hear, I've seen countless job advertisements for this kind of thing saying that you need to have this waterfall cycle understanding and such, and to be cognitive of it. But in truth, it's pretty old-fashioned and seldom works very well, especially when you haven't got fixed and firm project scopes to deal with. So the way to go, and something we're only going to cover as a basic overview here, is the agile software development. Now, agile is simply that, a way of being very dynamic and quick to change with your software lifecycle. And what that is a way that you actually you pull the actual client into the project in such a way that they have deliverables every 2 to 4 weeks, which makes them happy, and you change the scope of the project as you go along. So generally, you will want to consider the concept of agile working. And agile working is simply saying that we have a project that's this big, and we chop it into small sections, and each section we will call a sprint, and we will get that section completed within a sprint. But every single day we will have what's called a scrum. And a scrum is where we all huddle together in a stand-up meeting. We stand up because nobody likes to stand up, so the meetings are very short, where you discuss the day's development and what can be done the next day and the next day and the next day, and so on. You do that every day until the actual sprint is complete. And at the end of the sprint, you supply a basic prototype up to the sprint point to your clients, which makes them happy. They provide feedback, which then allows you then to continue the next sprint until eventually you get to the end of the project. So you generally have a project owner, a team, a scrum master, who is somebody who deals with the scrums, and then you perform sprints, you perform scrums themselves, and then eventually you finish the work. This is a kind of an overview, if you will, of, it's not very clear, is it, of a scrum in comparison to the waterfall. And essentially, most of the work happens in this sprint. So you have the product designing phase, and then you perform these sprints, and every 24 hours you have these little meetings so that you can assess the work that's going on. And they're very, very efficient. So this is just to highlight the concept of that. We are running out of time. So the difference in an agile versus waterfall is simply put that a waterfall is very linear and an agile is very recursive. So you can actually change an agile project on the fly without much of an overhead, whereas you have a waterfall effect, it can actually cause huge delays and huge problems within the project generally. So with that, a quick summary on the general terms of today's lecture. So we have the throw, to signal an error, you throw a new exception. The exception can be one of the classes available to you throughout the API, or you can create your own. You catch exceptions within a try block, so you try to perform some activity which then catches a given number of exceptions, either one or many or none if you don't want to catch it at all, but you must deal with it. Somewhere along the code, whether you're dealing with it within the method that's catching or whether you're passing it on to the next try block, that's entirely up to you as a developer. The finally block always gets executed no matter what takes place, so you'll always have that code running, often used in mobile phones, often used in code where you need certain closing statements or certain codes to be performed before, even if a crash occurs. Unchecked exceptions should not be caught. You should fix them. So that if you have bugs such as division by zeros or out of bounds exceptions and stuff, you really need to sort of fix those bugs and not have them at all. So don't think of exceptions as catching errors that you can't be bothered fixing. Instead, think of exceptions as exceptional circumstances that may happen because of user interaction. And there's a big difference there. And then we just covered the basics of software engineering and focusing on the best processes to develop work and software within time and on budget. With that, depending on whether you want to go into software engineering as a job or whether you just want to become a better coder, if you can get on board with an agile project and see how it works compared to a waterfall method project, you'll see the differences is night and day. They work very fast, you get a lot done, and you feel good as well because you're producing work at a regular basis. Anyway, with that, we'll call it a day. Is there any questions before we move on? Everyone happy? All right, guys, I shall see you for the last lecture next week. I will make sure that that other lecture from last week is put on hopefully by Wednesday. It will be recorded tomorrow morning properly on this system finally, and then it takes time. I upload it, which takes a few hours, and then it has to crunch it down to a readable form for you guys to see. But I'll send you a message on that account as soon as it's done. Thank you, guys.